Hello guys, welcome back. In this video, let us understood some more detail about this ML based NLP model. In this ML based NLP model, actually this is the advanced version of this statistical NLP model. In this ML based NLP model, now let's understood how input processing of model working happens. Here also same like in statistical model, here also we will learn the relationships and patterns. We learn the relationships and patterns. Relations and patterns only we will learn. Instead of learning them by using statistics and probability, here in ML based NLP model, we use training algorithms. What are they? Training algorithms. These are the advanced algorithms that we're gonna use as a base in order to learn the relations as well as the patterns of the data to predict the response and generate the response. Either it may a next word or the response may be anything other thing as well. If we are using this ML based NLP model for natural language processing, for natural language processing, if we consider this ML based models, then a new techniques are introduced, that is text classification models like logistic regression and or Navi based algorithm or SVM algorithm, that is support vector machine algorithms, are the famous algorithms that we actually use in this ML based NLP model for text classification. Regarding processing or prediction, we use neural network based models. Nothing but we have RNN model is there, TNN model also there, recursive neural network and convolution neural network. These are the famous text classification algorithms. So whenever when this era came, that is processing our natural language by using ML models. So during this era, actually what we are doing, we are learning the relations and patterns of data by using our model. So on what basis we are learning the relationships or patterns of our data? Based on the training algorithms. Based on what? Training algorithms. So it is important for us, right, to know the best training algorithms which are the famous that we're gonna use in this ML based models, so that we're gonna get best response for the given input, right? Yes. So the best training based models for text classification are Navy bias. This is useful for less, that is a small text purpose, and this system vector machines as well as this linear regression are used for text classification for large language models. So by using these famous algorithms, we're gonna classify the text. We can classify the text. Then we can further increase this. We can further increase this by using neural networks. We can further enhance this by using neural networks like RNN, that is a recurrent neural network, and CNN, that is convolution neural network. So we combine these two algorithms to make use of processing our NLP, that is a natural language and provide a great ML model for understanding the relation and patterns present in the data. Then, based on the given input, it will identify the relations and patterns. And by using that training model, it will predict the next upcoming words or outputs. So let's analyze this ML based NLP with a small example. For training my model with some data, for training my ML based model with some data, you can say I have taken some corpus that is nothing but some sample data to train my model. Then, so this is my model that is sequential that I am importing from, you can see TensorFlow.keras. So from TensorFlow.keras dot models, what I'm doing, I'm importing this sequential. This is nothing but the model, and this LSTM actually used for, let me tell you the full form. LSTM stands for long short term memory. So in order to store the memory for long short term, I am importing this layer from TensorFlow Keras, and dense to convert the data into dense, and embeddings to convert the data or data to embeddings. You can see this corpus is nothing but the sample data that I have taken to train my model. And you can see I'm pre-processing my sample data. I just converted the given or my sample data into lowercase. And now I'm picking only the unique words. So from this, I'm picking only the unique words. You can print it so that you can able to see unique words. Okay, right? Yes. So I'm saving this and I'll run it. You can see from this only unique words will be picked, and those what we are doing, we are printing here, right? Yeah. So let's see the output. What response do you get? Yeah, from here we'll get the response. I think each and every word will come just once, because the duplicates will be removed here whenever we use set for these words. Actually, this words is nothing but a list of words. Actually, this is a string. What we are doing, we are splitting that based on an empty space. That means it will pick only each and every word will be stored in these words. Then from that also we are picking only these. I think I have not saved this code. Yeah, we got the response, you can see. So fun one time and great one time. So like this, only once all the unique elements present in the given string, whatever the given string that I provided, those I got as the response, right? Yes. Then word to index. So for each and every word, what is the index that I am storing? And for each and every index, so what is the word corresponding to that index? So those two I have stored in these two. And now here for this sequence, what I'm doing is I'm storing word to, I'm converting word to indices. That is in my original words, here actually at here we haven't picked, till here we haven't converted the string into unique words. Here if you observe, the words will be same like I comma love comma programming comma is comma fun, like that the data is stored in this words. Then here, so for these words, indexes will be stored here. Indexes will be identified and stored here for these words. So that happened here. Then, so this is nothing but the training data. This is nothing but the training data. So whenever we call it with our sequence, what is this sequence? The sequence is nothing but word to index list. So that sequence will be sent to it, and by using that sequence, what we are doing, up to 3 length separation, that is so I'm picking first 3 words and storing that data in this X variable. And next word, what is the next word for those 3 words? That word I'm actually storing in this Y variable. Nothing but for this input sentence, what is the next word that is predicted, that I am storing in this Y variable. So like that, I have stored from starting length to ending length. Then I am returning those two, that is for these X values. So what is the Y values, or you can say for the given input in X value. So what is the next predicted value that I am storing in Y? This is the input predicted and this is the output predicted. Those two I am returning the value whenever this function is called. You can see I'm storing those two in X and Y. Then by using those two for the X value, for the given X value, I'm providing this Y as the result, right? Yes. So that I am training it to one model, that is the sequential model. You can see the sequential is nothing but that I have imported from TensorFlow.Keras models. I imported that sequential. This sequential is nothing but predefined training algorithm. I'm using this predefined training algorithm. Now, then I want to train my algorithm. For these inputs, these are the outputs. Like that, I want to train my model. So for that, this is the simple command to train my model. Model.fit and x comma y are nothing but for these x inputs. These are the y outputs, corresponding outputs. So like that, I provided, and these two are epochs and webos. Those two are nothing but parameters. So why these lines are needed? The requirement of these lines are nothing but, so if you take this model, what happens is it will only remember the last processed output. Only one single processed output only will be stored in this. So in order to store more number of results, does it require some memory? Yes, it requires some memory. So that's why this LSTM is used. What is this LSTM? Long short-term memory. With how many units it will remember? 50 units it will remember. Up to 50 results, this model will remember right now. So like that, based on your requirement, you need to remember more number of results or units in LSTM that you need to add to your model. This parameter, LSTM parameter that I have added to my model. From where I imported this LSTM? From TensorFlow Keras layers, I imported this LSTM embeddings and dense. Then even I've added the parameters like embeddings as well as dense in order to convert my data or whatever the data that I provided to this model into embeddings and dense, and process the data and get the response back. After providing these configurations, what I'm doing, you can see I'm compiling my model so that these configurations will be updated. After that, I'm training my model with for corresponding input. These are the corresponding outputs. So like that, we are fitting our model with corresponding data. So then, yeah, then you can see what we're doing. We're printing the response. That is nothing but, so till here training got done. Now we can able to use this model in order to predict the next word. What is the upcoming word? Here, if you observe what we are doing, we are using one predefined or trained algorithm. From where we picked that trained algorithm? From TensorFlow Keras models. We are using that trained algorithm. Okay, we trained that model with our input and output. Then we are using that model. We are now using that model, trained trained algorithm model we are using now. In this ML based natural language processing era, we are using these type of trained algorithms. Okay, now how we are predicting? So here also the same thing, we are defining a function and we are providing the current text, and we are passing the number of next words that we are expecting to the number of next words that we are expecting, that also I'm providing here. So whenever this function is called, you can see the request will came to here, and for the five times, this will be iterated, because the next word is nothing but this, that will be iterated for how many times? 5 times. Okay, so this will iterate for the 5 times, and each and every time what happens is my next word will be predicted, and that will be added into this seeded text. So what is the seeded text? The seeded text is nothing but what are the input that we provided. So here actually the process happened. The next word will be predicted by using our model. You can see I have written the comment, that is model.predict of current token list that I am passing. So based on the current token list that we are passing, the next word will be predicted, and by using the next word we are adding, or we are feeding that we are feeding the data into this seed text. Now you can run this so that you can able to get next predicted 5 words. I'm just running it so that the last result will be visible at the last line. Okay, let's wait to get the response of it. In this way, actually, we'll use these ML based models in order to process. So for processing my natural language, to predicting my next upcoming strings, by using what we are using here in order to predict my next upcoming words. Here I am using ML based algorithms, nothing but trained algorithms I am using. By using those trained algorithms, what I'm doing, I'm just training already available trained models with my sample input and expected output data, and then I'm providing my given input to my model, to my trained model, to predict whatever the expected output. Okay, you can see. So what is the input that we provided? This program is fun. So what is the response that we get? Program is fun, learning, then also it will pick learning, new. I think it is not providing me the more accurate response, or best response output. Even though we are using the trained model, we are not getting the highly accurate or expected output, right? While predicting my next word, I'm not getting the expected output. So this is the reason why we are moving further. That is other than these model, that is other than that trained algorithm model, to predict our pattern as well as the relation of the sentence, by using these trained models or trained algorithms. These are even not providing me the correct response or appropriate response. So that's why we are having a requirement to move further for another model, or requirement of advanced model than these ML models, to generate me the text. Even though this ML based models are not much accurate to produce the next words, the next upcoming words, but these models will overcome the issues that we face at this statistical NLP models. So while using the models at statistical era, those issues we are faced, which were overcome by the ML based models in this era. Basically, during the evolution of these ML based models, the text classification, it provided the solutions, and for neural networks, it provided the solutions. Even though some issues got resolved at this model, like text classification and neural networks, and neural network analysis, we are even having further requirement of advanced model than this. So that's why the another model, that is embeddings based NLP model came. Embeddings based NLP model came. So before moving to this, let's discuss some major issues as well as the use case of this as well. I have told you that these models, ML based models, are best useful for text classification. So for that also I want to show you an example. To show you the example for text classification, you can see now I'm picking the logistic regression from linear models. What I'm picking? Logistic regressions. So where these are present in sklearn. In sklearn, these linear model are present. In this linear model, I have this logistic regression. This logistic regression is nothing but a trained algorithm. I'm using it in order to predict whether the given text is classified into positive type text or negative type text. You can see, so for predicting, I provided some sample text and I've also provided labels related to these texts. This first text represents it's a positive one. This second text represents it's a negative one. So like that, I provided that is I provided some 6 samples with their inputs as well as text as well as the predicted outputs or you can say responses in labels. Then you can see I'm using this count vectorizer. So from where I imported this? I imported this from sklearn features extraction.txt. From sklearn features extraction.txt, I imported this count vectorizer. So by using this count vectorizer, what I'm doing? I'm fitting the transform, that is these texts into X value, and into the Y value, I'm storing these labels data. Then I'll use those two in order to fit into my logistic regression model. That logistic regression model that I have taken from this linear model in sklearn. After training my logistic regression with this X, or you can say with this sample inputs and with this expected outputs. So what I'm doing after training my model, that is logistic regressions, what I'm doing, I'm just taking the text of question, that is I had a great time. So like that I want to provide the question. Since this is a positive sentence, I know that this is a positive type sentence. So how can we say it is positive based on the model? If I got 1 as the result, then I can say it is a positive result. Otherwise, 0 I got, then the model is predicting the given sentence is negative. So in order to predict that response, you can see vectorizer. So where this vectorizer is present, this vectorizer is nothing but the count vectorizer that we extracted from feature extraction dot text from where sklearn, that we are using, and transform vectorizer dot transform of what are the given text that we have provided, that we are transforming into vector format. This vector format actually we not able to understood. For each and every word, vector representation is a different. I'll show you that as well. And we are passing that vectorized data into our model to predict. You can see model dot predict is the method that we are using in order to predict the response for this given input, for this given vectorized input, right? Yes. Now I'm just running this by using py main.py. Yeah. So since this is a positive word, I need to get a response like positive. So 1 I am getting. So what does represents 1? 1 represents positive. I love this product. It's a positive. I'm representing it with 1. This bad, it's negative sentence. So that's why I'm representing it with a 0. Okay. Now let's make it negative. That is I had not I had not a good time. So like that I provided sentence. I know that it's a negative sentence. Let's see the output, whether I got 0 or not. Yeah, you can see I'm getting the 0. Okay. So in this way, actually what we are doing, we're first taking the, or you can say, we're just using this logistic regression, and we're just using this logistic regression, that is nothing but a trained model, or you can say trained algorithm we are taking, and we are fitting that with, we're training that trained algorithm with some x values as well as y values. X is nothing but the inputs, and for these inputs the predicted output we provided, and we trained our model with these data. Then what we did, we provided some sample input or sample question to predict the output, whether this model is providing me the correct response of classification of this text into either positive or negative words or not. So currently our model is working good and providing, that is, and it is classifying me the correct response. So in middle you might get a question, that is, what is this fitted transform, or what is this transform, vectorizer dot transform. So actually while feeding or while fitting our inputs into our model, we need to provide only values like integer values. It does not accept these type of strings, these type of words won't be accepted by this. So that's why we need to convert that into vectors. First we are converting this text input into vectors, and this label is nothing but actually it's a integer value, so that we are passing normally here. And you can even observe how the vectorized data will be. So if you print here, then for this only one vector will be printed, so that's why I'm printing this. What is that? Text underscore x, text underscore x, yeah, tst, yeah. So test underscore x, so it will print me the binary, or you can say it will print me the vectorized value of x. For this input, what is the vectorized representation? You can see this is how the vectorized representation of this data will be taken. So for representing the data in the form of vector, what we are using, this count vectorizer. Count vectorizer I'm using in order to represent the data in the form of vectors. So like that, I converted my data into vector. Since it's a single value, like since it's a single sentence, these two values I got. So here you can see fit transform. In this fit transform, for this fit transform, what I'm passing, multiple sentences I'm passing. So I might get a multiple multiple values like this. This representation we call it as a vector. So I'd like to show you these x values as well. So that's why I'm printing this x as well. Like this, you can able to classify your data by using already available models. You can see, yeah, multiple vectorized data I got, right? Yes. This is how actually the vectorization happens. This is how actually the vectorization happens. And after converting your data in the form of vectors, you're training your model. That's nothing but you can say I'm training my model, and then I'm providing my input, and I converted that input into vector format, and I'm predicting the response by passing that vector formatted or converted input into my model, and I'm printing at last the response. So like this, actually in real time, you can use any ML based models or Gen AI based models or advanced models also to get the predicted response. So this is the main use case of ML based models. In this way, you can able to classify your text data among multiple categories by using famous models like this logistic regression or Navi base or support vector machines trained algorithms. You can use them for doing this text classification. In the similar way, you can use these models with this RNN or CNN to provide some computation to the classified output, and you can even use LSTM, that is a long short term memory, that you can even able to use for storing the output for longer time. That is, you can say you can able to store large amount of data and you can able to provide the responses as per your requirement by using this ML based NLP models. While using this ML based models, we are facing the issues like the first one is semantic. So what is semantic, sir? Word semantic, or you can say the semantics are missing. That is nothing but meaning, meaning of meaning of whole sentence, or you can say words are missing. So this is the one of the major issue that we face. Even while we are predicting the next word, what happens? The same word coming multiple times. That means the totally meaning is missing, right? Yes. So, and one more major issue while we face using this ML based NLP models are out of vocabulary words. So what does this mean? Out of vocabulary words means sometimes, so whatever the words that this ML model will receive, that will be out of vocabulary. If you use this embeddings based NLP models, they handle out of vocabulary words better than these these type of models. And here, if you observe, featured engineering is more. So manually, we need to provide some feature engineering. That means here in embeddings NLP, it allows for automated feature learning, reducing the need of manual engineering to make our model to learn the data. So these are the major issues that we face while using this ML based NLP model. That is, first one is missing of words meaning, and second one is out of vocabulary words may came to this, that handling becomes difficult here in ML based NLP model. Whereas in this ML ML based NLP models, we need to perform more of featured engineering. So in order to overcome these errors, we require the advanced model that overcome these major issues. That is this embeddings NLP model. I hope you understood this video and you got some knowledge regarding ML based NLP models and what are the how the working will be and what are the major issues, and so what are the major transformer or major trained algorithms for text classification and neural network processing and for increasing the memory to store the data in this ML based models. Famous models you have understood, and you have also seen the examples as well, real time examples with their program execution. You have also understood the limitations that we face while using these ML based models for NLP, natural language processing, and we also observed what is the next revolutionary NLP model, that is nothing but embeddings that overcome the limitations of these ML based models. I hope this video is useful. If you feel this video is useful, then please like, share, subscribe, and hit the bell icon to get the latest updates. Thanks for watching again. See you back in the next video with another interesting topic. Until then, bye bye, guys.